So today's video is all about me try to finish a project that I have started 1.5 months ago. It really took me a very long time to finish this project, and actually it's one of my dream project. I have worked really hard for it. So on today's video, I have tried to merge two musical components or two music instruments, I would say, like your one of is piano and another one is violin, and merge it together to make a one single musical instrument, or I can say an electronic device that can play music through thin air and by touchpads. So on first half of the video, you will find everything to make this project. I have given all the details, including circuit diagram, code, and all of the components that we're gonna require to make this project. And on the second half, you will see a story behind it. So you know why I choose to make this project, why I spent 1.5 months of my life to try to finish this project so desperately, right? So you're gonna love this. I hope you're gonna love this. And also in the second half, at the end, you're gonna see the output that it creates, and it's really fascinating. So I hope you like it. So yeah, hey guys, Saurabh here. Welcome back to my channel called Electro. So without any further ado, let's start the video. Let's take a quick look at the components used in this project. The first one is the ESP32 board. At the center of the system is the ESP32 board. It acts as the brain, handling all the sensor inputs, controlling the display, and sending wireless MIDI signals to my phone using the Bluetooth. Second one is the Ampere 1-to-1 touch sensor. For playing piano notes, I am using the Ampere 1-to-1 capacitive touch sensor. Each touchpad is made using conductive tape, allowing notes to be played with just a light touch. Third one is the ultrasonic sensor. To create the violin effect, I am using two ultrasonic sensors. This sensor detects hand movement in the air, and the distance is converted into musical notes. Next one, we're gonna use the OLED display. A 0.96-inch OLED display used to show important informations. It displays the selected instrument, played notes, and the real-time hand distance. After that, we're gonna use some push button to switch between piano mode and violin mode, and some slide switch for power switches for entire circuit. After that, we're gonna use a 2500 milliamp hour lithium ion battery, making it completely portable. For the safety charge, the battery I am using TP4056 charging module with built-in protections. Some components need a higher voltage, and MT3608 boost converter is used to step up the battery voltage. And at the last, all the components will be mounted on a 10 by 22 cm PCB board, giving the project a solid and compact structure. Then we're gonna use some female work strips for easy connection and future modifications. And finally, some connecting wire were used to link everything together, and a battery holder to hold the lithium-ion battery. Let's discuss about the circuit connection for this project. First, we will see the connection of the Ampere 1-to-1 touch sensor. So here you can see our touch sensor is connected through our ESP32 through I2C communication, which is SCL and SDA, and the positive pin of touch sensor is connected to 3-volt pin of the ESP32, and ground pin is connected to the ground of the ESP32. Since the Ampere 1-to-1 touch sensor need 3-volt supply only, that's why it's connected to the 3-volt pin of the ESP32. Now let's see the connection of our both the ultrasonic sensors. Both the ultrasonic sensors are connected with the ESP32 using echo pin and the trigger pin, and the positive pin is connected to the 5-volt of the ESP32, and the ground pin is connected to the ground of the ESP32. But make sure that both our sensor require 5-volt supply, not the 3-volt but 5-volt supply, and ESP32 cannot provide 5-volt supply through its pin. That's why we're gonna need an external supply for both the sensors, but make sure to connect the ground to the ESP32 to complete the circuit. Okay, so now let's check out our connection for both our push button and the toggle switch. So here you can see our push button and the toggle switch are connected to three different pins, GPIO pins of the ESP32, and the ground pin is also connected to the ground of the ESP32. Now let's move on to an important part of this project. So here you can see an OLED display, but in the component, when I was showing the component list, I didn't mention the OLED display, but right now I am mentioning it because I decided to add an OLED display to this project because it's gonna provide a really important key factor to this project, because we can show what notes we are playing, and we can also display the animation of the vibrato coming from the violin. Okay, so it's gonna make really good changes to our project. That's why I add an OLED display to this project. And here you can see the OLED display is connected to I2C communication to the ESP32 using SCL and SDA, and the BCC and ground are connected to 3V and the ground of the ESP32. And also our ampere 1 touch sensor and LED display both require 3V supply to run. That's why I connect both of them to the 3V pin of the ESP32. So that's our complete circuit connection for this project. I hope you understand it. Now let's do the connections. So now let's talk about how our project gonna work, how it's gonna function, right? Start from the ESP32 board. The ESP32 board has BLE connection, which make things more easier because we're gonna make it completely wireless. That's our primary goal, right? So we can connect it with any kind of mobile devices which has Bluetooth in it, and we can play any kind of, we can connect it to any kind of MIDI F, like FM synthesizer as an example, and we can play any kind of musical instruments like piano, like virtual musical instrument like piano, violin, guitar, drums, etc. So in our case we are only playing two instruments. We can play more than two, okay, but mainly we are playing two instruments, that is the piano and the violin. Okay, so in case of piano I am using the ampere 1:1 touch sensor, the touch capacitive sensor, right? So it has total 13 touch pads, but I am only using 10. So we're gonna play 10 different notes using this ampere 1:1 touch sensor. All right, now let's talk about this ultrasonic sensor. So this ultrasonic sensor we're gonna use it to play the violin notes. Okay, so how it gonna works now, the ESP32 will calculate the distance between the ultrasonic touch sensor and my hand, and it's gonna change or convert the distance into MIDI notes, right? And it's gonna play the violin, different notes of the violin according to the distance. So we can move our hands in front of this ultrasonic sensor and it can play different kind of tunes. Now let's talk about this push button. All right, so what is this function? What is the function of this push button? Now it will help us to change from piano to violin. Okay, so when I wanna press, in default cases it stays on the piano case or piano mode, and when I'm gonna press the push button once, it switch to the violin mode. So now the touchpad will not work, only the sensor will work. But in reverse case, now the only in piano mode, now the only touchpad will work, okay, but the sensor will not work. Okay, so it vice versa. So here you can see when I change it to the violin mode, here you can see in the display it's showing the different distance of the sensor. When I'm moving the hand in front of my sensor, the distance showing on the display, it also changes simultaneously. So how it's gonna work? Now the distance will convert it into MIDI note and it's gonna play the violin. So here you can see I'm using a different module to give supply to my OLED display and the ultrasonic sensor. So it providing me the 5V supply, you can see on the display right here, right? So yes, my OLED requires 5V because in the manual it shows that it will work on 3.3V, but when I gave it 3.3V it does not work. So that's why I decided to give it 5V, and now it's worked completely fine. In your case maybe it will be different, so make sure to check it out. And also one more thing, that it is now completely wireless and functionable, but the second most important thing is I wanted to make more cell power. I wanted to make cell powered device. That's why I'm also using a 2500 mAh lithium ion battery and also a charging module to power this whole circuit, right? So that will be our final goal, and we're gonna combine all these components in a single PCB board. Now let's combine all these components and make it a single complete project, right? So let's do this. So while I am soldering all these components on this PCB board, let's dig a little bit deeper inside this project and learn how it's actually working and learn about how the code is actually works. So here our main objective is to play a violin without strings and a piano without the keys, right? So using just hand movement, touchpads and an ESP32, today I will show you how this magic works. So this project is a dual mode musical instrument, right? So piano mode play notes using ampere 1:1 touchpads, and in violin mode it plays notes using hand distance with ultrasonic sensors. All the sounds are sent wirelessly via BLE MIDI to a mobile app or PC, and the OLED display will show the live information like patch name or note names, etc. The libraries that I am using inside the code are the wired.touch library for I2C communication, Adafruit MPR121 for capacitive touch sensing, Adafruit SSD1306 for OLED display, and MIDI plus BLE MIDI to send music wirelessly over Bluetooth. So this allows ESP32 to behave like a Bluetooth musical instrument. If we talk about the pin configuration, here we defines the MPR121 address for the touch sensor, of course, and the patch button to switch between piano and violin. I'm gonna explain it later. Two ultrasonic sensor like sensor A for lower octave notes and sensor B for higher octave notes. In the MIDI configuration, the MIDI channel is set to channel 1 and the program change is used to switch instruments from piano to program 0 and violin to program 29. This means your MIDI app changes sounds automatically when the modes switch. Note mapping is also the most important part in this code, which defines that each touchpad is mapped to a musical note like C, D, E, F, etc. In violin mode notes, sensor A is assigned with C4 to C5 and the sensor B is assigned with C5 to C6. So moving your hand closer or farther from the ultrasonic sensor, it gonna changes the note. Another small thing that I have added here is the note name conversion. So this function converts MIDI note numbers into readable names. Like as example, if it say 60, it will show C4, and for 62, it will show D4. So that's how the OLED shows real musical note names instead of numbers. Now let's talk about the ultrasonic distance reading. We all know how the ultrasonic distance sensor works, right? The ultrasonic function, it sends a trigger pulse, waits for an echo, converts time into distance in centimeters, then returns -1 if no object is detected. So this keeps the system stable and prevents false notes. Another important part is the zone mapping logic. So in distance is divided into 8 zones, right? So for sensor A, 8 different zones, and for sensor B, 8 different zones, right? Each zone corresponded to one musical note. So when our hand is near to the ultrasonic sensor, it wanna lower the note, and whenever we are increasing the distance between the sensor and our hand, the farther the hand, the higher the note, right? Smooth and natural violin-like control. In our main loop, how everything works, now the most important thing is here the patch button. When you press once, it switch from piano to violin. It's switching the patch inside that FM synthesizer app that I am using from 1 to 30. So that's why it's switching from piano to violin. When you are in piano mode, the violin will not work. That means the ultrasonic sensor will not detect. Okay, so but when you press the push button, it switch the mode from piano to violin, and then the ultrasonic sensor will start working and play the notes, and the OLED updates instantly. In piano mode logic, ESP32 checks which touchpads are pressed, and on touch, the MIDI note considered as on, and on release is considered as off. So OLED shows the current note name. This gives the real piano style behavior. In violin mode logic, ultrasonic sensor continuously read hand distances. So distance maps to a note zone. So when zone changes, old note turns off and the new note will turns on. Then the OLED will updates every 80 milliseconds. This prevents flickering and watchdog crashes. And most importantly, for the watchdog safety, we added a tiny delay at the end which keeps the ESP32 alive, prevents random resets, and make the system stable for longer use. So this is all about how this project actually works. I hope you get it. 2 months ago, I didn't plan to build a piano. I just wanted to finish one unfinished idea. It all started with an invisible piano. No keys, no buttons, just air and imagination. I wanted a completely wireless cell-powered MIDI instrument. While building it, I realized distance is how a violin is played. This wasn't just a piano anymore. It became two instruments on one board. Sensor failed, code crashed, but I didn't stop. Now, when I move my hands, music comes out of thin air. I didn't build this to replace instruments. I built it to reimagine them. Now let's see the magic in action. This is not just a piano, it's a touch plus air gesture instrument. These touchpads work like piano keys. Just a light touch, no pressure, and the note plays instantly. And look at the OLED. It shows the exact note I'm playing in real time. Now here comes the most coolest part, the ultrasonic violin. No strings, no buttons, just hand movements. As I move my hand in the air, the pitch changes just like a real violin. And this subtle handshake adds vibrato, giving it a realistic instrument feel. Everything you hear is sent wirelessly using BLE MIDI directly to my phone. Touch for notes, air for expression, and that's why I call this a digital violin piano hybrid. So this is my final Gesture Violin Pro MIDI project. It has some drawbacks, I can tell you that, but I will change it or I will fix it in my future videos. And this is what we create when the electronics meets with the music. This is an electronic musical instruments. And I hope you guys like this video. If you love this video, give it a thumbs up, share it with your friends, and hey, don't forget to subscribe my channel guys. Until then, keep innovating, keep practicing. See you in the next one. Peace out.